Welcome to the Q&A session 27 from the chapter of electric charges and fields. The topic is the calculation of work done in rotating an electric dipole when it is placed in a uniform electric field. So this question which I have taken for this session was asked in the IIT-JEE main exam in the year 2025. That is, this question was asked in this year itself. The language of this question is slightly different from the original question. However, the question is almost the same. So the question here is the charges of an electric dipole are placed at -900 and 900 centimeter. It is placed in a uniform electric field of intensity 10 to the power 4 Newton per coulomb. So we have to find the work done in rotating this dipole from its position of stable equilibrium to its position of unstable equilibrium if the magnitude of each charge of this dipole is equal to 100 microcoulomb. So in the session number 25, we have learned that the work done in rotating a dipole is equal to PE in bracket cos theta 1 minus cos theta 2, where theta 1 is the initial angle between the dipole moment and the electric field, and theta 2 is the final angle between the this dipole moment and the electric field. That is, this angle, that is theta 2, is the angle between the dipole moment and the electric field after the rotation of the dipole. Now this is the first thing. Now second thing is that here we have to find the work done in rotating the dipole from its position of stable equilibrium to the unstable equilibrium. Now in the case of stable equilibrium, theta is equal to 0 degree, that is the angle between the dipole moment and the electrical field. That is, the direction of the electrical field is equal to 0 degree. And in the case of unstable equilibrium, theta is equal to 180 degree. That is, the angle between the dipole moment and the direction of the electrical field is equal to 180 degree in the case of unstable equilibrium. Now here P is what? P is the dipole moment, which is equal to the separation between the two charges of the dipole multiplied by the magnitude of any one of the charge of this electric dipole. So P here, first of all, we have got the value of E. The value of this electrical field, that is the intensity of the electrical field in which this electric dipole is placed, is equal to 10 to the power 4 Newton per coulomb. So E is available to us. Theta 1 is equal to 0. Theta 2 is equal to 180. Now we have to simply find the value of P. Now P is the dipole moment, and this is equal to the distance between the two charges, which is equal to 0.18 meter. Here it is, if I draw this is the x-axis and this is the y-axis. So if one of the charge is placed at -900, so this is the origin. So -900 will be the position of one of the charge as shown in this figure, and this will be 900. So this is the position of another charge of the dipole. So the distance between these two between these two charges is equal to 18 centimeter. In meters, it will be equal to 0.18. Now here, this dipole moment will be equal to the distance between the two charges multiplied by the magnitude of any one of the charge, which is equal to 100 microcoulomb. So this will be equal to 100 into 10 to the power -6 coulomb. So we have found the value of P. So the work done will be equal to 0.18 into 10 to the power -4 into the intensity of the electrical field, which is equal to 10 to the power 4 in bracket cos theta 1. Now theta 1 will be equal to 0 degrees, so cos 0 is equal to 1 minus. Now theta 2 is equal to 180 degrees, so cos 180 is equal to -1. So this will be equal to -1 plus 1. So the work done will be equal to 0.18 into 2. Yes. And this is equal to sorry, 0.18 into 2, sorry, into 10 to the power minus 4 into 2 into 10 to the power 4. So this is going to, this will get cancelled out, and finally the work done will be equal to 0.18 into 2. This is equal to 0.36 joules. So the work done in rotating this electric dipole from its position of stable equilibrium to the position of unstable equilibrium will be equal to 0.36 joules. So thank you very much for joining this session. Now in the next session, I will be continuing with the same topic of electric dipole, but in the next session we'll be having a different question. So till then, have a nice day. Bye.